This is a particle podcast. WA Science told different, powered by Scitech.
Please Look Up is recorded at Scitech on Whadjuk Noongar land. Good evening, everybody, and welcome to Please Look Up, the monthly podcast produced by Particle, where we take you through a guided tour of the night sky as seen from Perth, as well as taking a deep dive into some of the more out-of-this-world space news. In this episode, we'll be discussing what you can see in the night sky in the month of December. My name is Leon, and I'm joined by Amanda, a professional presenter from the Scitech Planetarium. Amanda, thanks for being here.
Thanks for having me.
So, Amanda, let's start this podcast like we always do. And can you please tell me, what can the casual observer expect to see in the sky this month? What planets are out there?
So Jupiter and Saturn are still up. Jupiter in the northeast and Saturn in the northwest. Now, Mercury is out at sunset, but that can make it a bit difficult to see. So I would recommend using an app like Sky Safari or Stellarium to help you find it. Mm-hmm. And then Venus is in the east before sunrise. So if you're up nice and early, you can watch where the sun's rising and see if you can spot Venus, which will be very bright in the eastern horizon.
I unfortunately was up early the other day and I did see it.
Oh, there you go. So you would know. And then, well, the only one you really can't see is Mars because it is exactly behind the sun. So we won't be able to see Mars for a couple months.
All right. So technically, if you look at Mars, you're kind of looking at the sun, which is another way of saying it's out during the day.
Yeah, don't do that.
Okay, no, don't do that. And Jupiter and Saturn and Mercury is the nighttime planets.
Yes.
It wasn't that long ago Jupiter was over in the east, but in the last couple of months it's kind of moved a bit higher up to the northeast. Is that right?
Yeah, its orbit's kind of taken it up.
Okay, and if I remember correctly, out of Jupiter and Saturn, is it Jupiter that's going to be the brighter of the two?
Yes, so Jupiter is much bigger and also closer to us.
And therefore much brighter in our sky.
Exactly.
Makes sense. Okay, and Mercury, yeah, I've tried looking at Mercury before, but it's kind of hard to spot, so...
Yeah, it's quite small.
Yes, so some sort of app. What did you say? What were the apps?
So you can use Sky Safari or Stellarium.
Beautiful. All right, I'll check those out. All right, so those are the planets that are out in the sky this month. What about any interesting constellations? You always have really interesting constellations to talk about.
So last time I was here, we did talk about Parvo the peacock.
Yes, I
or
remember.
giant space slug.
The space slug, yeah.
If we keep it on the theme of birds, there is another bird right near Parvo. It's called Tucana. Any guesses which bird that would be?
That's definitely a phoenix.
Not quite. That would be Phoenix, which is just above Tucana. But Tucana is the toucan. Yep. So it's a small constellation in the southern sky, and it can be a bit hard to see in Perth because of all that light pollution. So if you're out, I do recommend getting one of those apps like Sky Safari and Stellarium to see if you can spot it to find a new constellation you might not have seen before.
Gotcha. So it is a toucan, just in case anyone thought I was being serious.
No, it is a toucan.
A toucan. Okay, and so there's a few bird constellations out in that direction by the sounds of it, and Tucana is the one we're looking at this month. And what is in Tucana to look at?
Yeah, so Tucana itself, not the most interesting looking constellation, and like I said, a bit faint, but there are some really interesting things in Tucana. For example, there's the Small Magellanic Cloud.
I have heard of that. Can you tell us about the Small Magellanic Cloud?
Yeah, so the Small Magellanic Cloud is a small galaxy just outside the Milky Way. It's called the Small Magellanic Cloud because it's in contrast with the Large Magellanic Cloud just next to it.
Right.
Yeah, so these are kind of much older, not fully formed galaxies.
Oh, right. Okay, so they are other galaxies. I thought so, but they're outside the Milky Way.
Yeah, so there's some conjecture, but most people think they do orbit around the Milky Way.
Right. Okay, so a bit like the way the moon orbits the Earth. These smaller galaxies orbit the much larger Milky Way.
Yep, and then we travel through space together.
Okay, and are they called the Magellanic Clouds because they look like clouds?
I've never asked the people who came up with the names, but they do look quite like clouds. Again, you wouldn't see them in Perth, but if you were out somewhere in the outback with no light pollution, they would look like hazy clouds.
Oh, I see, gotcha. So you need to be away from light pollution if you want to see the Small Magellanic Cloud.
Yes, or even the larger one. They are very faint. You won't see them from Perth. But yes, if you're out in the outback away from light pollution, you'll definitely be able to spot them. They're worth looking for.
Gotcha. Anything else in Tucana? This sounds like an interesting place.
Yeah, so there is 47 Tucana, which is a globular cluster of about 500,000 stars compacted into just 150 light years across.
Whoa, that's quite a lot.
Yeah, that is actually quite dense, yeah. So it is a very interesting place to look, especially if you have a telescope, because there is a lot of stars out there to look at.
Just doing some quick maths here. So 500,000 stars in 150 light years across is about 1 star per sort of light year on average. The nearest star to the sun is like 4 light years away. So yeah, that's way more dense than the Milky Way galaxy. Wow, okay. And do we know, where do globular clusters come from? What are they?
Well, we're not sure, to be honest. There is some speculation that they might be the hearts of ancient galaxies that the Milky Way has eaten away. But again, like I said, we're not totally sure of that. We know they're extremely old, about 12 billion years or so. They're older than most of the stars in the Milky Way, the stars that make up the globular clusters.
Wow, okay. That's a really interesting thought. So yeah, it's possible that the Milky Way has stripped away most of an ancient galaxy and all that's left over is these globular clusters.
Yeah, that would have been right at the heart of that galaxy.
Right at the centre there. Yeah, gotcha. Possibly, but you've said, still not quite sure.
Yeah, that's just some speculation based on what we're observing is left behind.
Yeah, gotcha. And what sort of science can we do with globular clusters? Or can we do anything if we don't even know where they come from?
Yeah, so astronomers have used the Hubble Space Telescope to look for planets in 47 Tucana around any of the stars in that cluster, but they weren't able to find any. So this leads us to think that planets don't form around these older stars, which was something that we'd speculated before. But upon looking at these old globular clusters like 47 Tucana and not finding any, we see that, we generally find exoplanets, planets around stars besides our sun, to exist around newer stars.
Right. Oh, and as you've just said, the globular cluster is about 12 billion years old.
Yeah.
So yeah, those would be like some of the very original stars, the earliest stars in the universe.
Yes.
Like more modern stars have been sort of recycled a few times, like the sun, for example.
Exactly. So those older stars don't have as much metallicity, basically.
Oh, yeah. I see what you mean. More complex elements that
Exactly.
you kind of need to make a planet. Okay, so I guess that vaguely makes sense, doesn't it? Well, I guess it's good to see it backed up by some actual data, though. All right. Any other interesting news? What else is happening in December?
Yeah, so there's a couple of things to look out for. There is the summer solstice on December 22nd.
Ah, yes, the summer solstice. I keep hearing about it on December 22nd, you say. What is the solstice? If you can please remind us again.
Yeah, sure. So the summer solstice is when the sun reaches its highest point in the sky. So we have the longest day of the year and then, of course, the shortest night.
Ah, okay. So I knew it had something to do with like the longest day of the year or something like that. If I wanted to observe this without staring directly at the sun, how do we observe the solstice?
Yeah, so the best way to do it is to watch for sunset, or if you're a bit of an early bird, you can use sunrise. But we'll go with sunset. And you just mark where the sun is setting against the horizon every day. And from December 22nd, you'll notice that sunset starts to shift and occurs more and more north as we head past the summer solstice.
Oh, I see, right. Oh, okay. And at its most southern point on the solstice, that's obviously when it's highest in the sky.
Yeah,
That makes perfect sense. Oh, there we go. And is this related to the seasons?
Yeah, I think we talked about the equinox last time I was here. So we briefly mentioned, the season. So this part is where we're getting summer from, basically. So when the sun is high up overhead, its sunlight is beaming directly down onto the ground. And so there's more sunlight per square metre, basically. So it's a lot warmer. Whereas as we head into winter, the sun will be lower in the sky and it will hit the ground at an angle, meaning that same amount of sunlight is spread out over more ground. Yeah. So it's less warm.
Oh, okay. And all right, that makes perfect sense. And hence why it's called the summer solstice, because it's right up high and it's, as you say, straight down almost. And that's why we get the most concentration.
Yeah, exactly.
All right. That's great. Any other exciting news in December?
Well, there's, of course, one very important date we can't forget, December 25th, Isaac Newton's birthday.
Happy birthday, Isaac Newton. All right, let's leave Earth behind for a little bit. Is there any other interesting big news in the wide world of space?
Yeah, speaking of leaving Earth behind, there was the second orbital Starship launch that occurred by SpaceX.
I did hear about this. I saw in the news that it blew up, just like the first one. So what happened this time round?
Yeah, well, first of all, let's talk about what was meant to happen.
Yes,
So
what was meant to happen?
The rocket and its booster were meant to launch off the launch pad and then head into space, where then stage separation would occur. So the booster would separate from the top rocket, and then it would be guided down to land in the ocean, where it could then be recovered.
That's the booster you're talking about?
Yes, the booster.
Gotcha.
And then the rocket would go up into orbit and orbit once around Earth, when it would then fall back down into Earth and be recovered in the ocean as well.
Okay, so that was what was supposed to happen. What did actually happen?
So it did successfully launch off the launch pad, which is a great start. And then we did have stage separation.
Okay.
So the booster did separate from the rocket. However, within a few seconds, it did explode.
Oh, okay.
Yeah.
The booster exploded.
The booster exploded.
Gotcha.
So that's the first part that didn't quite go to plan. However, the rocket did then continue on and make it to space, but didn't quite get to orbit, and it also exploded then.
Oh, okay. So that certainly sounds more successful than the first one.
It's more success. They've gotten further this time.
Yeah,
Last
they got all
time
the
they
way to
didn't even
space.
make it halfway to space.
So we kind of just glossed over it there that the second flight was better than the first flight. Do you want to just remind us how did it compare to the first flight? What happened on that one?
Yeah, so the first launch took place in April of this year. And well, during that launch, when it blasted off the launch pad, it did kind of destroy the launch pad.
Just what, the engines themselves?
Yeah, literally, like the engines do create a lot of force, and they just exploded the launch pad as it tried to take off.
Right. Good start.
Yeah, no, it's not a good start at all. In fact, it didn't even get halfway to space before the rocket and the booster still connected. So before we even got to stage separation, it all blew up.
Right. Now we know what went wrong with Flight 1, and I can see you've just described Flight 2 went better. Why did it go better? I'm guessing there were some improvements. What happened?
So they did look at a few things. The first one was that launch pad, because critically, not great for your launch pad to just blow up when you blast off.
Right.
Does impact how you're going to get up there. So what they did was install a sprinkler right under where the booster of the rocket is, and it helps cool the launch pad and avoid it blowing up.
Right.
And it seems to have been successful in that the launch pad didn't blow up this time. So
Okay, cool. I'll call that a success.
yeah.
So that was the launch pad. What else did they do?
So they changed the steering of the rocket. So the way you steer a rocket is by changing the direction that the engines are facing.
Okay, you just kind of swivel them about.
Yeah, exactly. But the way this was done in the first version in April was actually through using a hydraulic system. So an old-fashioned kind of power steering arrangement that would move the engines for you.
Right. Okay, so they're using like fluids, basically pumping fluids into pistons to steer the engines around.
Exactly.
Okay.
The same thing that happens in your car.
And they've replaced that, have they?
Yes. Well, you know, Elon Musk, a fan of replacing hydraulic systems with electric. He has changed this steering system to be using electric engines to move those rocket boosters. So now they have that fallback so they don't have to worry about the hydraulics failing, and they have an electric engine that'll swivel them.
Oh, okay. Yeah, right. That makes sense. That actually does make sense. Very straightforward. Because, yeah, if you lose, if a pipe breaks and you've no longer got fluid flowing to your engines, you can't steer the rocket.
Yeah, so it's actually what happened in that first launch, the steering, they had issues with it. So it might not always have issues and you can rely on it, but if something does go wrong, then you will lose the hydraulics and you won't be able to steer it. So it's just about improving reliability there.
Gotcha. That makes perfect sense. Have they made any other changes to the rocket?
So this was their first go at implementing hot staging with their rocket.
Hot staging. Okay. That's an interesting word. What 2 words? What does that mean?
So to properly put it in context, we should probably go through what normal staging is first. So normal staging is what typically happens with a rocket. So when it reaches that part in its trajectory, the booster switches off and then it separates.
Right,
from
so that's
the
stage
rocket.
separation.
Yes, that's the stage separation. And then the second rocket fires its engines and the booster falls away. With hot staging, the second stage rocket actually fires its engines before that stage separation has occurred and the booster has launched off. So what you're literally doing is firing a rocket off of another rocket.
Wow, that sounds interesting.
Yeah. And it seemed to work this time. I mean, we did have successful stage separation.
Yeah, we did.
It's just then a few seconds later, the booster rocket did blow up and we were kind of hoping that wouldn't happen.
Right.
I mean, we don't know that the hot staging caused that, but I think they'll be investigating and asking some questions and hopefully get to the bottom of whether that was the cause.
Right. So, yeah, we're not quite sure yet. And you mentioned that the second stage went on for a bit and then also blew up as well. Do we know why that happened?
Not as of yet. They haven't really released that. But SpaceX is pretty good about doing its investigations and then releasing its reports on its findings. So it will be something we'll be able to follow up with and find out what happened if they discover the point.
Yeah, cool. Obviously, there'll be an investigation about that launch. But apart from that, what happens next? Is there more Starship on the horizon?
Yeah, they've got a whole bunch of Starships ready to go, and it'll be a similar process from what happened between April and now. They'll investigate what happened and make some adjustments and hopefully figure out how not to get that booster rocket to explode, maybe see if we can get the second stage rocket into orbit and what changes they need to make to get that to happen.
Wow, third time's the charm, hey?
Let's hope so.
All right, well, thank you so much, Amanda. It's been a time and a half. Thank you for being here on Please Look Up.
Thanks for having me.
That's it for this episode of Particles Please Look Up. We'll see you next month when we talk about the night sky and the space news for January. If you want to hear more interesting space news, check out the website particle.scitech.org.au for more information.